Hi there, welcome back. And to this, our final lecture, wherein we're going to be examining our schema creation log to see how, in fact, to create objects within our database. All very good. Up to this point, things have gone along pretty well. We've looked at how to create and drop users, manage privileges with the grant and revoke statement, how to create objects within the database, how to alter tables, things like that. It's all very good. We're going to step it up a little bit in this particular lecture by looking at sequences and triggers. Triggers are written in Oracle's special procedural language, PL/SQL. So this is going to be us dipping our toe into that water as well. We'll go much deeper later on in this course, but for right now, we're just going to use PL/SQL to create a couple simple triggers. We'll talk about it when the time comes. All right, let's dive in and start taking a look. Okay, guys, time to reopen that create schema log. I think we called it temp.txt or something terribly creative like that. Go ahead and open that guy back up and scroll down to the command where it says create sequence, customer ID sequence. Okay, let me know when you're all caught back up. Pause this thing if you need to, but once you're ready, then let's fire this thing up and start our analysis back over again. All right, create sequence, customer ID sequence. Anybody want to guess what this syntax is doing? Sure, it's creating some kind of database object called a sequence. An Oracle sequence is a special kind of schema object used in association with all these false primary keys. Been around forever, has had these false primary keys. If you create a sequence, you can then ask that sequence for its next available integer and then use it as the row's primary key. Very, very common practice, and one, quite frankly, I recommend. Let's see how it works. Pretty straightforward, actually. Looks like this specific sequence is going to be named customer ID sequence, be initialized to a value of 1, and increment by 1 each time we query it. No cache keyword is pretty straightforward. You should all know what this does. It basically says don't bother keeping a bunch of these in memory. I won't be using them often enough to bother wasting the resources. The alternative, of course, being cache. No cycle simply says do not start back at 1 after reaching some arbitrary maximum value. Similarly, I could have specified min and max values and then cycled through that loop. Not really applicable for these false primary keys, but it's easy to see where in the real world these would be valuable situations and you'd want to emulate them and create a sequencer to do that. All right, the next set of commands does what is known as creating a trigger, and it's doing so via PL/SQL, Oracle's procedural language. You can use PL/SQL to create any of 3 different types of objects. Triggers, which fire on the change of a table. Procedures or functions, which are called by other procedures or functions. You should be familiar with that as programmers. And then packages, which are nothing more than a collection of procedures and functions. Okay, given that little bit of background on PL/SQL, noting that we're going to get much, much deeper into it near the end of this course, it's now time to take a look at this very trivial piece of PL/SQL and see how this trigger is actually behaving.
Let's check out this first line of PL/SQL in our trigger. It reads, create a replace trigger before insert customer. Looks like we're either going to create a new trigger or replace one which already exists of the same name, in this case before insert customer. By the way, that's pretty standard trigger naming convention. Okay, that name is a nice introduction to our next line in this trigger, before insert on customers. I just said triggers fire on the change in a table. That change can be an insert, update, or delete. In addition, you can have the trigger fire before or after realizing that change. For example, our trigger here is going to fire before records are inserted into the customers table. Okay, given that information, question: what's the maximum number of triggers on a table? Careful, the answer is 6, not 8. Reads are not a triggerable event. I have a before and after insert, before and after update, and before and after delete. While I'm on this topic of 6 possible triggers per table, let me get on my soapbox for just a moment and say that too many triggers in a design can seriously mess things up. To use a before insert trigger to set ID fields is perfectly reasonable. To use triggers to start realizing more sophisticated business logic is a very bad idea. Put that stuff in a procedure or function, not your triggers. Having a trigger update other rows in the same table or rows in another table is a remarkably bad idea. The phenomenon is known as a mutating trigger, i.e. a trigger which updates itself or circles around the schema and comes back to subsequently update itself later. Remember when they told you recursion should be avoided in your programs for this very same reason? After a certain point, you can't possibly know what's going on anymore and you lose control of your own code. Mutating triggers have the potential to invalidate data within your schema. As such, if Oracle detects that a trigger can in fact, and it doesn't have to, all it has to be is potentially mutating, it will invalidate the trigger and you can't use it. Note, please use triggers with only very simplistic logic. All the rest of that business logic goes into procedures which don't mutate. Okay, off my soapbox and on with this lecture. Back to our code. Next line simply reads for each row. Simple enough. If we're inserting a bunch of rows, I want you to execute this complete code for each row in that set. The correlate, of course, is to omit this clause, and then the trigger will fire only once before insertion of the entire set. Given that you're all programmers, the next line is pretty obvious. It's just declaring myself a variable of type integer to be used further down the line in code. Let's just briefly mention the begin and end statements which serve to delineate the trigger code. Easy enough. Again, as programmers, you're used to learning something by just seeing the new syntax as an example. Similarly, the / after the end command simply tells Oracle to go ahead and compile this trigger. Exception handler is also pretty straightforward. Basically says that if anything goes wrong here and the trigger generates an error, just send a message to the user that they should contact the DBA. You generally don't want to throw Oracle errors at the user. You normally want them just to go get somebody who actually knows what's going on. Finally, let's examine the code that actually executes every time a row is inserted into the customers table. Looks like we begin by selecting the next value from our previously defined customer ID sequence. We then chuck that next value into a previously declared myID integer variable. Let's not worry about dual for right now. We'll get to that soon enough. But for now, let's just say that it's a table owned by system where sequences can get a value. The next line reads :new dot customer ID : equals myID semicolon. Could it be that we're basically saying, hey, I want to assign that myID variable to the customer ID field of my new record? You bet. Again, new syntax, but very straightforward once you see it. It's easy enough to clone. What did we do with this sequence and trigger? We assigned what we now know to be a unique primary key. Right, hooray for us. Let's all celebrate the proper use of a before insert trigger.
Oh, baby. I know what you're all thinking. Oh, Rick, that was great. Give us some more. We're drinking from the fire hose now. I love this stuff. I mean, we're all programmers. We get off on new syntax and new ways of realizing logic. What's the answer? I'm going to step up my game just a little bit then, and we're going to look at the code associated with the before insert trigger on the customer addresses table. So move on down the log to create trigger before create a replace trigger before insert customer addresses. And let's take a look at that code. If you'll recall, the customer addresses table is a many-to-one with the customer table, and customer addresses records cannot exist without the existence of a parent customer record. All right, given that information, let's check out the code associated with the before insert customer address trigger. Let's jump right to the meat of the issue, as you should already be familiar with most of this syntax by now. Our query reads, select NLV left paren max left paren address underscore ID right +1 right comma 1 right into my ID from customer addresses where customer underscore ID equals new dot customer underscore ID semicolon. Whoa, we better break this guy down and then work our way out on these parentheses. Let's start with the bottom section first. A lot more straightforward. Select whatever the heck that top stuff is from customer addresses table where the customer ID equals new.customer ID. What is it saying? I'm just going to tell you here because we haven't studied queries yet. Go to the customer addresses table and get me all that top stuff, which we'll look at, where the customer ID of a row is equal to the customer ID of the row I'm about to insert. Okay, that's pretty plain. We're going to go look for the previously entered customer address records with the same customer ID as the current one. And we're going to do this before we do this insert. We're going to do it for every row we insert. All right, now let's work through that top stuff, starting, of course, with the innermost parents. Okay, remember that the bottom section of this query went out and got us the set of all customer address records with the same customer ID as our current record? This max address ID clause is simply saying, give me that single record from that set that has the maximum ID value. Okay, I mean, we're all coders, we're big boys and girls, we understand it. For example, let's say that the bottom part of this query returned 10 customer address records, all with their customer ID matching that of the current ready-to-insert record. This max ID clause is simply saying, of those 10 records, give me the one with the maximum address ID value. For the sake of an example, let's just say that address ID value would be 10. All right, what does this next little piece say where we are adding 1 to that value? Well, if it's 10, I want you to actually return a value of 11. Easy enough. And I bet you already see where the rest of this example's going. Let's move on and try to understand the rest of this little query. Something about a NVL. What the heck is an NVL? Well, maybe that is a function testing for the existence of a null. What if the bottom half of this query had returned 0 rows? What if this was in fact going to be the first customer address associated with a particular customer? Then the max ID +1 section of this code would have returned or evaluated to null. All the NVL function does is evaluates the first parameter for the existence of null. If it is null, the second parameter of the function is returned. Net. No customer address records found for this customer ID. Set my ID to 1. Ta-da! We have a working counter for the addresses of this customer ID. Well, at least in theory. But more on that in the next lecture when we start testing these triggers. Okay, gang, we just got our first introduction to PLSQL sequences and triggers. Exciting stuff. What did we learn? We learned that we can use a before insert trigger and a sequence to very effectively assign the value of a primary key segment. It works beautifully and it's very common practice. We also got a little warning about mutating triggers. That is, any trigger which potentially updates the same table and or cycles around the database and ultimately back to the current table, thus making an inconsistent update. Oracle's not going to let you do it, and once you get into this mutating trigger mess, you are down a rat hole, and the only way to fix it is to pull all this stuff out into procedures and functions, which, by the way, is where it belonged in the first place. All right, in our next lecture, we're going to finish our discussion of DDL by taking a look at how we modify and alter a table once it exists, how we modify and alter other objects within the database, and then finally how we test these triggers once we've got them in place. Should be great fun. We'll see then. In the interim, you know where this is going. Got to have some fun, but learn something every day.